Good Monday morning. Hello, seventh grade. Hello, seventh grade. Hello. Hi, everybody. Hi, everybody. Let me know as you guys kind of come into this here. Let me know if everything's running well. Sound's going well. What's up, Tristan? How you doing? What's up? We'll get started here in a second. What's up, Nathaniel? What's up, Katana? We'll get started here in a second. If you guys have like a pencil, piece of paper, I mean, that'd be great to have kind of going along with this. Like I said, if you have a piece of paper or whatnot, yeah, go ahead with this. Try to make the most of this. Started here in just a second. Yes, Tristan, I did. So we're going to be talking here. About 1 second here, guys. I'm sorry. So kind of dealing with, we'll be solving a problem involving circles. Solving a problem involving circles. Dealing with, dealing with scale drawings, triangles, etc. I put a 2 in front of there. I'm sorry. Yeah, dealing with scale drawings. There we go. Good stuff. Good stuff. So, if you had paid attention to my Google Classroom post, you'll see that I talked about this, about having a good Sunday. I'll be referencing online content. I'm going to try my best to go through this. Again, it's different with being in this kind of a format, just because I don't have you guys in front to kind of bounce questions and thoughts and everything off of. Having you guys come up and do things, interactively, all that kind of good stuff. So, bear with me on this. Okay, this is probably what we'll probably do with this is it's going to take today and tomorrow to go through, but I do want to kind of, whether or not you are with me now live or on demand. What I'm going to do quickly here, though, is I want to open this window. Locked. Oh my. I'm going to be putting out there on Google Classroom. What's up, Nick? How you doing, man? Here we go with this. Okay. What I'm going to be doing is I'm going to be putting out there on Google Classroom under the classwork. It's going to be an assignment. I put it as that because it's to be able to reference this sheet. Okay, to be able to reference the sheet that you see right here. What's up, Kishan? How you doing, man? So, sorry, bear with me here, but on this, I'm going to be putting a link to this under Google Classroom. It's going to be, you can be able to open it up within Pearson. I'm trying my best to deal with technology right now. Oh my, there we go. Sign this, and you'll see this. And again, it's just something to reference. If you cannot reference it at this point, that's totally fine. It's just something to help you kind of, read along as I'm kind of going through this. Again, this takes the whole entire, the whole process of this will, will make sense once it's done. You got lunar and Venus with this, and I'm going to put this out there. And what you should see is if you go into Google Classroom and go under classwork, this will take its sweet time, you'll see where it says this student edition e-text right here. Again, if it's something for you to reference as I'm going along with this, whether or not you're live or on demand. If you're on a computer, if you're on a phone, it's almost pointless to bring that up because it'll take way too long, just because that's the way the website works. But with that being said, I want to bring up what we're going to be working on here. Now this is the first part. All right. Again, we've been talking about more like surface area scale drawings, triangles, circles, all that kind of good stuff. Yeah, I think my thing's running a little bit bad here, Nathaniel. I hear you. I'm going to try to give it a second to kind of. How am I doing now here? Stream health. Yeah, I got a poor stream up. Yeah. How about now? How am I doing now? No clue why it's doing that. Still poor. It's not good for you guys. I'm sorry. Am I doing all right now? Let me know. Let me know in that chat. Sync. Okay. All right. Thank you. Thank you. Again, try to make the best. Try to make the best of this. I'm going to try to keep myself off the screen with this for now. So what I want to do is I want to start off with this. So again, I want you to bear with me on this, but like, if you looked at this net, and it said to you, if I said to write a fraction, so here's the question that we have. We're writing a fraction that represents the ratio of the number of faces of the square pyramid. So the number of faces of the square pyramid to the number of faces of the rectangular prism. Okay. What would be a fraction that represents the ratio? So you would start off on this with, we know that we're writing a fraction, right? We know that we're writing a fraction. It's representing a what? A ratio, right? It's representing a ratio, correct? So a ratio, remember, a ratio is a comparison of two items. It's a comparison of two things. Comparison of x to y, the comparison of apples to oranges. In this instance, it's the comparison of the number of faces of the square pyramid to the number of faces of the rectangular prism. All right. So the number of faces of the square pyramid, and if we're looking at our square pyramid, right here. Our square pyramid has how many faces? Well, if you look at this, remember, anything pyramid, if you see anything pyramid, a pyramid means the faces come to a point. They come to a point. Everything comes to a point. I'm sure you all have seen pictures of, pyramids, out in ancient Egypt, anything of the sort, around, that have been created. Pyramids will come to a point on that. So in this instance, a square pyramid, it has the base of a square. So your base of your square, and the base of the square here, the base of the square is going to be one face right there. And then you have your four sides here. 1, 2, 3, and 4. So the four sides will eventually, when put together, when the net is put together, will come up to a point on that. So how many faces do you have on your square pyramid? It's going to be 5. So it's 5 faces. Okay, so it's 5 faces. with a square pyramid. Its comparison to the number of faces on the rectangular prism. So the rectangular prism, so let me do that in a different color. Rectangular prism. We know that a rectangular prism, if we were to write this, we were to draw this put together, we were to draw like a 3D image of it put together. Draw your little dots underneath like this. If you draw it underneath like this, yeah. So like in this instance right here, you have your top, you're gonna have your bottom, and then you're gonna have your one on the right, your one on the left, your one on the front, and then the one behind. And so the amount of faces on that square on that rectangular prism is going to be 6. It's going to be 6 faces. So it's 6 faces. So when we look at this, and we say, well, what is the fraction that represents the ratio of the number of faces of the square pyramid to the number of faces? Oh my God! Did I just go? Happen? Oh. Can you guys still hear me? Am I still going here? Let me know. Can you still hear me? Am I still going here? Please let me know. My app just died on me, so I'm trying to see exactly, am I still going here? Okay, there we go. I think I'm good now. Am I good on this? Oh my. Oh my. Anyways, yeah, I'm gonna keep going here because it looks like I'm still streaming here. Okay. Dang it, my phone went completely, YouTube went completely dark on me there. Unreal. Okay, so again, so the ratio that compares the faces of the square pyramid to the rectangular prism is going to be 5 to 6. So that ratio is going to be 5 to 6 on this. 5 to 6. 5, 5 to 6. Okay, that's the ratio. So then it says write two fractions that are equivalent to this fraction. And it says, well, what two fractions can be equivalent? Well, what's an equivalent fraction? You can take 5 over 6 and you can find a common multiple of both the numerator and the denominator on this. So of the numerator and the denominator on this. So if I took that numerator and I multiplied by 2 and I took that denominator and multiplied by 2, an equivalent fraction would be 10 over 12. Correct? 10 over 12. So 10 over 12, right? Restart. What are you using? Yeah, how am I doing? Am I good? All right. So, can you hear me? La 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 la. Can you hear me? That right there is an equivalent fraction. Yeah, I'm trying, guys. I'm sorry. I'm sorry. I'm sorry. So if I have that 5 over 6, if I have that 5 over 6, I want to find an equivalent fraction. I want to sit there and multiply both the top and the bottom by the same number. In this instance right here, I can take a 2. I can take a 3. I can take a 4. I can take a 5. I can take a 10. I can take a 254. I can take a 254 or a 9,204. So, like if I were to take 5 over 6, another equivalent fraction right there is if I were to sit there and say I could take both the bottom, top and the bottom multiplied by both 5. I could take 5 by 5. 5 times 5 is not 30. 5 times 5 is 25. 6 times 5 is 30. An equivalent fraction would be 25 over 30. Again, if I were to say that's the two equivalent fractions, that would be what it is. What it is on that. Okay. Hopefully that makes a little bit of sense. Evidently, my stream is just deciding to want to just totally just go cuckoo kachoo on this or whatever the wording on that is. What am I using? I'm using broadcasting software. It's called OBS. It's called OBS. OBS. That's what I'm using. OBS. And evidently Spectrum doesn't like me. So Spectrum doesn't like the fact that I'm using broadcasting software or some weird stuff like that. Yeah, it's just a combination of OBS and YouTube. That's all it is. That's all it is. That's all it is. So I want to give kind of a breakdown here of what I would like to get into on this. What I would like to get into on this. Now this isn't this one. Let me get the other stuff off. Okay. This is something to where it requires breaking down the whole entire process to really understand, what this does. When you first start with this, it's kind of like, well, what does this even make sense with? And what we're doing right here is dealing with like what we call mathematical modeling. So your idea with what we're going to run through here today and today and tomorrow or whatever you or with me on demand or whatever, you'll be able to identify a relationship among variables, develop a model that represents the situation, use the model to propose a solution. You're given a problem, you're given a real life problem, you want to try to use your thought process. Think, well, what's she trying to do? What's going on here? How can I find the answer? If I'm posed a question based on what I saw, how can I find an answer, to that question? Okay. Yeah, and the thing is with this, not every person's prediction is, everybody will have a different prediction. I mean, everybody have a different prediction. I mean, it's different. I mean, everybody's different with this. Now, how this starts out with, and this is if we were together in class, I'd run through this with everybody because this is something to where showing the whole process of mathematical modeling will help understand how to properly, attack certain questions. You'll be able to sit there and I know for those of you I've worked, pretty good one-on-one with, when it comes to questions, and I would say, well, let's look at the question and say, well, what doesn't make sense? Well, what can I do to kind of, knock down the answers that they don't make sense? But in this instance right here, how it starts out with is I start out and I throw a video across, and it's like a minute long video. It's nothing really long, and it is different than sixth grade, and it will be different than eighth grade. But it's just something to deal with that will hopefully, I guess, help a little bit better when it comes to these last few weeks. Decide to open. But the idea with this is to watch the video and then to answer what would be called Act 1 questions based on this video. Act 1 questions based on this video. Again, this is where I was saying in my Google Classroom online there, I was saying like, well, have something to write with, because I'd be referencing these questions. I'd say, well, what about number 1? I said, well, after watching the video, what's the first question that comes to your mind? What questions? I mean, and you'll see here. We'll get started with this and try our best to kind of power through this. All right. So what I'm going to do is I'm going to play this first video, or the only video. It's a whopping 32 seconds. So 32-second video. I'll kind of talk over it once it's done, and I'll go from there. All right. Whopping 32 seconds. A couple things to remember before we start kind of me talking through this a little bit. You see in this that she's wondering whether or not she should get a bunch of small pizzas or get one giant pizza. Evidently, she's obviously in a pizza shop and she's sitting there trying to order pizza and all this good stuff. I will see. Let me get back to you on that, by the way. All right. So let's see here. So on this, so you watch this video. So you've watched this video here. Watch this video. And you're kind of sitting there and you're saying, well, what the heck does that even mean? What are we even talking about here? So you look at this and it says, well, what's the first question that comes to mind? Now, a lot of times on this, a couple of good potential ways when I looked at this, you just say, well, how big is the pizzas? How big is these pizzas? How many small pizzas fit into the big pizza? When you order things from any like a Pizza Hut or a Papa John's or Domino's or anything of that sort, you say to yourself, do you want to get a couple of small pizzas or do you want to get one big pizza? And you say, well, I think another couple of questions that I have is to say, well, what's the price? What's the price of each small pizza? What's the size of these pizzas? You start thinking into that mindset of saying like, well, what is the cost for each small pizza? Is it, if I plan on getting 4 small pizzas, is it going to be as much as one large pizza? And a lot of times when you're in a store, you're sitting here and you're saying, well, do these 4 pizzas cost? It's called having like a cost efficiency. You say, well, 4 pizzas, if it's like $8 a piece, I can get a large pizza for $20-something or whatever it is. Do I get more pizza for the large pizza or more for the small pizzas? And you're coming to that kind of, you're weighing those different those different issues right there. So we look at that number 2 and we say, well, what's that main question you'll answer? Well, I kind of referred to this, that main question in this instance, that main question, I'm going to put this actually in the chat. That main question in the chat right there. All right, that main question in the chat is going to be, well, how much does that big pizza cost? How much does that big pizza cost? All right. Now, based on what you know, so then you say, well, based on what you know, if you looked at, if you then proceeded down with this, and again, if we were in groups, I'd have you guys say, well, what about if we wanted to kind of change this up a little bit? I'd say, well, maybe if we were in our 3 groups that we were usually in, I'd say, well, maybe group 1 would be people who were in, downtown New York City or downtown San Francisco or somewhere where the price would be like this, compared with out in Kansas City where there's nothing within 30, 40, 50 miles of everything. You can be able to come up with different, like I said, to construct your arguments with this, predict an answer to the main question. And again, with with this instance right here, you can come up with any different thought process. You can sit there and you can say, well, I have, um, I have, um, what would affect that price? Where was it at? What are we using for our toppings and all that kind of good stuff. And again, it's just trying to get your mind into this. We'll get into number 4 here tomorrow because I'm about to be done with this just for time's sake. But we'll talk more about this and get more into this tomorrow. This is something that you'll see. You'll see. We'll do this tomorrow. Kind of roll through this. Again, I suggest if you can, if you're physically able to, take a look at this and just have it reference to reference. We'll get more in depth. This is all about modeling. It'll make sense about it once it's all taken care of. Just muted my Chromebook. That's okay because I'm actually about to get rolling with this here. Sean, to answer your question, email me please. Email me, okay? All right, email me, and we'll work something out, okay? All right. Um, but with that being said, I hope everybody's having a good time. Good time for what it's worth. We'll get more back into this tomorrow. I hope you all have a good day, and I'll talk to you guys soon. All right, now I'm done.